Hey guys, so it's time to start solving logarithmic equations. So in this one we are looking at sort of simple equations where we have an exponential or a log on one side that x is stuck inside of, and then we're going to be using our newfound tricks to solve for x. So first example, 6 to the power of x is equal to 40. Now we could actually do this two different ways. So for this one example, I'm going to go through it both ways, but we're only going to use one method throughout the rest of the video. So the first method, we could convert this from index notation to logarithmic notation. So our base is 6, our power is x, and our result is 40. So we could write this in terms of logarithms as log base 6 of 40 is equal to x. Now if you put that into a calculator, we would get, therefore, x equals 2.059 to 3 decimal places. So that works fine. It's not really the method that we're going to use though, especially when we get to trickier ones. So now that we're armed and dangerous with our laws of logarithms, we can solve this in a different way. So what we're going to do is take the log of both sides. Now it doesn't matter at all what base log we use, so either use just log, which is log base 10, or ln, either one is fine. Why those two? They're on your calculator. Okay, so if we take the log then on both sides, we get log of 6 to the power x is equal to log of 40. Now, on the left, using the laws of logarithms, we know that log of 6 to the power x is the same as x log 6. So that is equal to log 40. And remember, we're solving, so we want to get x on its own. So what we do now is divide both sides by log 6. So we would get x equals log 40 divided by log 6. Now be very careful there, you can't combine those at all. The 40 and the 6 can't simplify because they are stuck in the logarithmic function. So if you put that in your calculator, you will again get x equals 2.059 to 3 decimal places. So that is the sort of method that we're going to use going forward. Okay, next example, we got 2 to the power of 3x equals 100. So log both sides. So we get log of 2 to the 3x is equal to log 100. Then, by the third law of logs, the power of the 2 on the left hand side comes down and sits in front of the log. So we get 3x times log 2 is equal to log 100. If we then divide by log 2, we get 3x is log 100 over log 2. Now we don't want 3x, we want 1x. So if we also divide by the 3, we get x equals log 100 over 3 log 2. Now if you like, before you turn to your calculator, you could here write that as log 100 over log 8. So the 3 at the start of the log on the bottom can go inside and act as a power of 2. So if you put that in your calculator to 3 decimal places, we will get x equals 2.215. Good times. Okay, this is a really nice example of why logs are actually quite useful. So we can solve this equation where we have powers on both sides. Not only that, on the right hand side though, imagine how huge 5 to the power of 100 is. It's 5 multiplied by itself 100 times. So we can use logs to solve this, which without logs would be a complete nightmare. So we want to get x on its own, so our first step is to log both sides. So we get log of 2 to the power 3x equals log of 5 to the power 100. Now the powers, the exponents, go down in front of the logs, so we get 3x log 2 is equal to 100 log 5. Now if we divide by log 2, we get 3x is 100 log 5 divided by log 2. And then we need to divide by the 3, so we get x equals 100 log 5 over 3 log 2, which again personally I would rather take the power in on the bottom just to clear up things on the calculator. So we could write this as 100 log 5. So I'm not taking that power of 100 in there. Not sure how much a calculator would love that. I'm only doing it on the bottom because we then get log 8, which is a nice usable number. So if we put that into our calculators, we get x equals 77.398 to 3 decimal places. Okay, now we're going to take a look at a few examples where we start with a logarithm on one side and we want to solve for x, which is stuck inside of the logarithm. So for these, it's important to remember that logs and exponentials are inverses of each other. That means if you take an exponential of a logarithm, as long as the bases are the same, they cancel out, so you're just left with x or whatever is being logged, or vice versa. If you took the logarithm of an exponential, then it undoes that. Now that sounds a bit cryptic, so let's show you what I mean with this example. So here we have 2 log base 10 of x is equal to 3. So x is stuck inside of a logarithm. Now, there's something we can do nice and easily, first of all, and that is divide away the 2. So, we would get log base 10 of x is equal to 3 halves. Okay, so now how do we get the x out of the logarithm? Well, the log has a base of 10. So if we were to set the logarithm part as a power of 10, then the exponent and the logarithm cancel out. So we raise both sides to the power. We raise both sides as a power of 10. So we get 10 to the power of log base 10 of x is equal to 10 to the power 3 halves. Okay, let's have a look at doing one then with a natural logarithm. So remember again, ln just means log with a base of e. So if we've got log 2x plus 5 equals 10, to cancel out the log, we need to raise both sides to the power of, as a power of e. So we would get e to the power log 2x plus 5 is equal to e to the power 10. Now on the left hand side, e to the power of a log, or a natural log, they cancel out. So on the left we just get left with 2x plus 5. So 2x plus 5 is equal to e to the power 10. And now we just solve for x. So take away 5 and divide by 2. We get x is e to the power 10 minus 5 all divided by 2. So if we whack that in our calculators, then we get 11,010.7 if we go to decimal place. So sometimes you might be asked for exact form, which is up above e to the 10 minus 5 over 2. Sometimes you'll be asked for decimal places or sig figs. So just be aware of what the question is asking. Okay, last one for this video then, so I'm at least going to do a part 2, maybe part 3, where we move on to trickier examples. So, we want to solve log base 3 of 5 minus 2x is equal to 4. So, first of all, what's the base of our log? It's 3. So we're going to raise both sides as a power of 3. Now, on the left, that just cancels out the log, and we are left with 5 minus 2x is equal to 3 to the power 4. In previous examples, I've written in that step on the left where I would have written 3 to the power of log base 3, 5 minus 2x, but you don't need to. So, try and get in the habit of not doing so. Maybe try and write as little as possible if you're as lazy as me. Okay, so now we've got 5 minus 2x is equal to 3 to the power of 4. Now, if we add 2x and take away 3 to the power of 4, we get 5 minus 3 to the power of 4 is equal to 2x. Therefore, x is equal to 5 minus 3 to the power 4 all over 2, which we can work out. So 3 to the power 4 is 81. So up on top we got 5 minus 81, which is minus 76. So x is minus 76 over 2. Half of 76 is a number 38. So we get x is minus 38. Good times. Okay guys, that's it for this video. Hope it's helped. Take it easy.